I first talk quickly about Remato. So Remato is an all-in-one construction software. We build digital solutions for the small to medium construction companies, providing them with like crew management, task management, project management, and stuff like that. It has different modules, and it is cross-platform, can be used basically anywhere. So where does the problem come in is that, so the problem is that we describe tasks to the workers. So currently, when using Remato, the workers can see this huge table with all of the tasks and like statuses, projects, and like when they begin. And if they open the task up, they will receive this overview of the application, which has like the features of the application, periods, stretch time, and little descriptions. And this isn't usually enough. It needs plenty of pictures to do it, to actually describe the task to the worker. So as part of my master thesis, I proposed to create an AR application that would actually try to visualize the task that the worker has to do. So they can use the device to look around the room and see the specific spots and markers that they have to do. So here I have marked a little rectangle that makes this spider and some bags and stuff like that. Some requirements are that the application must contain the tools to mark the information down. That it will have to be re-visualizable. So if the project manager, let's say, marks the room and comes back later to that, let's say the worker comes back later to the room, the information will be still there. Basically, what you can see in the reality maker that the same information is seen by everybody. It has to have basic onboarding because construction workers are about 30 to 40 years old. The average construction workers, so they don't have this experience with AR applications, and only a few people have. So a basic onboarding is needed to the application as well. A video call and video manipulation features were added as well, because project managers have to be at different project sites at the same time. So they can't be at the same time at the different spots, so the worker can use their application to call the project manager, and the project manager can then help out and do some AR markings as well. So as part of my thesis work, I did a related work. I will quickly go through over it. Blob is an interesting application. It's created by Estonians. I don't know if any of you know it.
I do.
Yeah, yeah. So what they try to do is do like a messaging system. Like you can leave behind the private messages for your family, for your friends, and if the others come in, they can see it. And it was compared to the Remato AR because they both try to leave some kind of messages behind. In Remato's case, we try to leave behind some virtual information for the workers that could be useful, and in this case, it's just for fun. TeamViewer Assist AR is like for the assisting part in the augmented reality. I will quickly go over this. Visual Live is currently doing some BIM modules on top of the work in AR, and then there's Inspect AR that's basically doing the same thing that React Maker said to do. You can see the coffee machine and you can instruct the users change the water tanks and stuff like that. And then there's Industrial AR, and it's basically doing what Remato AR is trying to do, but they're using 3D scans of the room actually to do it. So they get this. Currently, in Reality Maker, you are using your own phone to create this point cloud, but for more accuracy, they use 3D scans of the room. So, and then using that, they can place different markers like rolled paper and stuff like that. In my implementation, I used these kind of technologies that the main application is using React Native and ViroAR for AR SDK. I could have used Unity, but as Remato is using React Native, this was a better alternative to actually introduce other developers to it. And Unity has quite a bad license for startup companies, so we went with React Native. And in the backend, I'm using Node.js to actually hold the information, and Postgre and OpenCV to do some feature detection. In the augmentation part, I implemented basic 3 objects. You can place texts, you can place polylines, and you can do 3D objects. These 3 basic things could be used to mark basically any information you need in the room. Then the important part of the application was the correct placement of the virtual objects. So I'm actually using QR codes to do it instead of the feature detection because the construction sites can change a lot during their development. So an easier way to do it, or the way I tried to do it, was just you put a little marking of QR code on the wall, the worker scans it, and then information is placed according to that QR code. You don't always have to look at the QR code to see the information, just the initial placing is done related to the marker, and then you can just walk around freely as you wish. But yes. Some other weird bugs that I had, like the detection, to make it more general, I made like an infinite plane to do it. I guess it is so important here, but it was in my thesis defense. And yeah, I do some correction via feature detection as well. Like current AR applications are prone to some drifting, and so I do a little, at the placement of the marker, I take the snapshot of the feature that is done and then try to detect it from the room. Like if there is like a centimeter drift, it should correct itself a bit by using this feature detection. And yeah, so information was there, and then it gets corrected to the actual center position. And the final feature that I implemented was a video call feature. I used the Augmented to do it. It has a really poor performance, at least on React Native. Then I used my own data transfer channel to do it and got 4 to 5 frames a second. And then I also added manipulation through video. So you can see I used 2 phones here. One is for like calling in, and one is actually reading. The same image can be seen by both of the devices. But yeah, I can talk as much as I want. This won't actually tell anything. I will just simply show a quick video for you. So yeah, let's say the project manager gets into the room, scans the initial floor. This is needed to actually know how the device moves. I have placed a little marker on the wall that the worker scans. Then the project manager does a little marking here. He marks the position of the sink in this example. This was made in my university lab, or not lab, but the defense room I was in. So I just marked the room down. I write a little message like replace the sink, and yeah, you can see that it's in the correct place. And now I will close down the application very soon.
Did you like drag over the sink or
yeah, just by drumming with your hand. You can just do it really quickly. Now the worker came in, started from the different positions, scanned the QR code again, and received the same replace sync information. Now let's say there is a confusion. He will call his project manager from Little Movie Magic. This is the other screen that the project manager sees. He will answer his call, and the same information is basically transferred over. The video call feed isn't so fast currently, but I'm working on it to make it better. So there I'm just showing that there's my hands. I just draw a line, then the line goes to the same scene, and then it will be marked down as well, and then some demonstration here as well. And yeah, the same information is done, and yeah, now I'm in the scene. Yeah. As a part of my master thesis, I also did a little bit of testing on the clients. 4 different project managers were tested, and it was done in 2 parts, like restricted testing, so that they had a to-do list, what they have to do, and unrestricted testing, so that they could do what they want. Some results that the tracking was okay-ish, like some drifting was still noticed, but most of the markers stayed in the positions that they were placed in. Ease of marking was like, I think this is cool for reality maker dudes, that actually the placement of the objects and working in VR is quite intuitive once they get the hang of it. It's like only one of the users rated quite poorly, but this was because of the tools actually that I was using. But overall, most of the users were really comfortable using AR, to track things and just place things down. And some general feedback for my application was that there needs to be more tools. Currently, it's better for work validation rather than the information. So, let's say project manager marks down the initial information, worker does some tasks on it, and then to check if the worker did a correct job, the project manager can go again and actually validate the work using the AR information. And yeah, there should be a simpler view for the workers as well. I guess that's most of it. Oh yeah, and the future plans is to implement most of the suggestions that were made during my testing cases, improve the video calling. As you saw, it was like 4 to 5 frames per second, it's quite slow. Combine it with Remato, so the actual in-task information will run between the two applications, and then additional testing like in a bigger scale.